Hello and good morning, grade 9 with you, Mr. Samir Awad. We are going today to continue our session about chapter 4, lesson 1, defining the atom, and that's part 2, talking about the size of the atom and how to use the tools in order to scan and to know more about the atom. But in the beginning, I have to scan about what we get in the beginning. Before, it was about the scientific theories and points of view of the scientists about the atom structure, and start in the beginning by Democritus. And Democritus the beginning, who was a philosopher or the Greek philosopher who started to get a definition for the atom as indivisible and indestructible part of the element that represent the element in any compound. And that was a good thing, but by the end, it wasn't good enough because there was no evidence or proof with it. And after that, after 2,000 years, yeah, scientists came and started to prove the evidence by experimental work and scientific principles. And he was John Dalton, the English one. He started to take that in his work to make his own theory, and it was the first atomic theory talking about the atomic structure. And now we are going to do part 2. So part 2 is talking about sizing up the atom and what instruments are used to observe individual atoms. In the beginning, we would say, if we get liquid mercury, as you can see here, guys, yeah, there is a difference between the size of droplets here, from the smallest one to the biggest one. But the common factor between all of them that they are made up of the mercury atom, and all of them have the same properties, whatever was the size, whatever was the mass for it. And that we can see here, yeah, that every drop, no matter the size, has the same properties. And even if you could make a drop the size of an atom, it would have also the same chemical properties of the mercury. On the other side, we'll get another example for it. It will be if you were to grind a copper coin into a fine dust. Each stick in the small pile of shiny red dust will still have the same properties of copper. If you start to grind more and more in order to reach the last part, yeah, as the particles are getting to be fine up till it reaches the size of copper atom, it will have the same chemical properties of, and that this particle is an atom. The other parts shown here about atoms that are very small. Here you can see that a pure copper coin that has the small size of the penny contains about 2.4 times 10 to the power 22 of atoms. It's like you are getting two of or double of the population of the people around the world. Yeah, by comparison to the Earth's population, it will be here 7 times 10 to the power 9 of people. On the opposite, if you get 100 million copper atoms side by side, one line, so you will get only to be 1 centimeter long, and that's too small to get it, and you understand that the atom is tiny and little than you expect. So despite their small size, individual atoms are observable with instruments such as scanning electron microscope. You cannot notice the atom by your naked eye, but that's a different thing. It's called, or a tool is called scanning electron microscope, or SEM or SEM. So scanning, because you can scan small particles, yeah, electron, because it can do that by electron beam or electron power here, and microscope because it can see the thing that you cannot see by your naked eye. So in a scanning electron microscope, a beam of electrons is focused on the sample. And electron microscope are capable of much higher magnifications than the light microscope, which we use it for medical analysis. With the help of electron microscopes, individual atoms can even be moved around and arranged in a pattern. And the ability to move individual atoms holds future promise for the creation of atomic-sized electronic devices such as circuits and computer chips. And that's made up of silicon, as we said before, guys. And the silicon here can be used also for the solar cells. It's very tiny, like you will see it in the processor of the computer of your cell phone. Is made up of tiny things like this size of the atoms. An example of a device made up of individual atoms is a nanocore shown here. You can see it. This nanocore, guys, is atomic scale here. You can see nanoscale because it's very tiny. It's like 1/billion of meter on this scale. So it could become essential in the future application for the medicine. As I said before, guys, for you in our interactive session, that sometimes we'll get, some robots made up of, nanoscales substance or nanosubstance that can start to get rid of the blood clot coming from the structs inside the blood vessels of the human. And that is very, very, very advanced. Also in communication, now you can hold only small speaker without using even wires or something like that. That's all about what the technology here is using nanoparticles to make that very small. Also, solar energy and spacecrafts there, used for exploration. That's also helping by the nanotechnology. Getting something is light to the space is better than getting something heavy. So let's get, some calculations here. I knew that calculations sometimes get into be, but that is very easy because if you have 1 centimeter, line long of atoms, the line, and the radius of one atom fit will be 1 times 10 to its power negative 10 of meter. So we'll see that you have around here 1 times 10 to its power 10 atoms of radius of 1 times 10 to its power negative 10. And that's too much. It's 10 billion atoms in this line of 1 centimeter. Can you expect that? So in 1 meter, you will get around 10 billion atoms. That's a very, very large number. Yeah. Okay, for that, guys, let's get the concepts we gathered within this lesson. Democritus reasoned that the atoms were indivisible and indestructible, and that was, supported by the evidence or experimental methods by Daltons, and transformed Democritus' ideas into atomic scientific theory. And also, we got scientists can observe individual atoms by using instruments and tools such as SEM scanning electron microscopes. Atom is the smallest particle of an element that retains its identity in the chemical reaction. And we get Dalton's atomic theory, the first theory to relate chemical changes to events at atomic level. Electrons and structure of the atoms. Atoms are the smallest particles of an element that still have the chemical properties of the element. Thank you for listening, guys. Be safe at home, watch the videos, work on your assignments and the worksheets through our interactive lesson. Ask as much as possible, and good luck, guys. Bye-bye.